In this lesson, we're going to be solving systems of equations by three methods. One's graphing, substitution, and elimination. Let's take a look at all three examples. Let's start with graphing. Our first equation, our first system is y equals 2/3 x minus 4, and y equals negative 2x plus 4. Now, when it's asking you to solve, it's pretty much asking where do these two lines that we're going to graph, where do they intersect? Do they intersect once? Do they intersect twice? Are they on top of one another? Do they never intersect? So these are the questions we're going to ask ourselves. If they intersect once, we're going to have one coordinate, which will be our solution set. So let's see what happens with these two lines. So if we're going to do this by graphing, we have y equals 2/3 x minus 4. We see here that we have a slope of 2/3. This is slope-intercept form, and a y-intercept of negative 4. So let's start there. We have a y-intercept, 1, 2, 3, 4. And a slope of 2/3, positive 2/3, rise 2, run 3, rise 2, run 3, and so on and so on. If we draw a line here, okay, so there's our first line, and again this line will go on forever that way. Our second line is y equals negative 2x plus 4. Again, here my slope is negative 2, and my y-intercept here is 4. I go up 4, 1, 2, 3, 4. And my slope is negative 2, so I'm going to go down 2, run 1, down 2, run 1, down 2, run 1, and if you notice here, this is my point of intersection here. So this coordinate is going to be 3, negative 2. So the point of intersection here is 3, negative 2, and if you drew the line here, you would see that that is the intersection point. So this is one technique we have here. We could draw the graphs and find out where they intersect. Let's take a look at another one. So we have graphing y equals negative 6 and y equals negative 2x plus 4. All right, let's start with our first one, y equals negative 6. We have zero slope here. This is a horizontal line here at negative 6. So if we go down 1, 2, 3, 4, 5, 6, what the graph of y equals negative 6 looks like a horizontal line passing through the coordinate negative 6. Okay, and our second equation, y equals negative 2x plus 4, same as before. I'm going to go up 4, and then I'm going to go down 2, run 1, down 2, run 1, down 2, run 1. And you can see how this is a little tedious here. And we have a point of intersection here. Okay, and our point of intersection here is going to be, we count 1, 2, 3, 4, 5. So we got 5, comma, and then we're going down 1, 2, 3, 4, 5, 6, 5, comma, 6, and there is our point of intersection. All right, great. So those are two examples of graphing. Now, sometimes with the graphing, what's not convenient is right now these are falling on perfect coordinates or perfect intercepts. When the graph doesn't fall on perfectly, then we have to guess or estimate where it is. Is it 5.5? Is it 5 1/3? So that might not be so ideal using the graphing method. So another method we have here is our substitution method. So we have two equations, y equals 2/3 x minus 4, and y equals negative 2x plus 4. So these are the same equations as before. So here's our two equations. So since we know that they're going to intersect somewhere, and one giveaway is this slope is negative 2, this slope is 2/3. So the slopes are not the same, meaning that they will intersect. So if the slopes are not the same, these lines will intersect somewhere. So if they're going to intersect somewhere, so at some point, and this equation is actually going to be equal to, so they're going to have, at some point, they're going to have the same y value and the same x value, the same coordinate. So these equations at some point will be equal to one another. So what we could do here, since they're both equal to y, or one coordinate that's the same, eventually, because they're going to be equal to one another, we can then just take these two equations and set them equal to each other. And this will help us find when the x-coordinates will be the same, or what x-coordinate will they both have at that one particular intersection. So let's solve this equation for x. If you want to clear your fractions here, you can clear your fractions. You can multiply through by 3. You got negative 6x plus 12 equals 2x minus 12. Okay, I'm bringing my negative 6 over this side, so I have 8x. Bringing my negative 12 over that way equals 24. And then here we see that x is equal to 3. So this is just one coordinate of the point of intersection. So we need both coordinates. We need the 3 and then we need the y coordinate. So you could go back into any one of these equations. I'm going to go back to this bottom one here. So negative 2x plus 4. And since I have the x coordinate here, I'm going to plug in or substitute in for my x coordinate. So this is going to be y equals negative 2 times 3 plus 4. If you solve this, you get negative 6 plus 4, which is then in turn equal to negative 2. So the point of intersection here is 3, negative 2. Let's take a look at another substitution. We have x plus y equals 4 and y equals 5 halves x minus 3. Alright, so this equation is already solved for y. So this is y is equal to this quantity here, 5 halves x minus 3. I have this equation x plus y equals 4, so I have x plus whatever my y value is equal to 4. So what I want to do is I want to substitute in the 5 halves x minus 3 here. So 5 halves x minus 3, because that is what's equal to y. Right, so I took this y and I put it in here. So now let's solve this equation. So I have x plus 5 halves. I could drop my parentheses here. I'll just rewrite it. Minus 3 equals 4. I can combine like terms. So 1x plus 5 halves x is 7 halves x. And bring my 3 over, adding 3 to both sides, which is equal to 7. So now I have 7 halves x equals 7. I can multiply this by its reciprocal, 2 sevenths. Multiply this by its reciprocal, 2 sevenths. My 2's will simplify, leaving me with just x. X equals, and I'm left with x equals 2. Now again, this is just the x coordinate. Again, I need the x and y coordinate, excuse me. So let's go back and plug in or substitute in and find our y coordinate. It doesn't matter which equation you choose, either one. So if I go into this one, so I got y equals 5 over 2 times 2 minus 3. We notice the 2 simplify here, so I'm just left with 5 minus 3, which is equal to 2. So the point of intersection is 2, 2. All right, our third method here is elimination. We have x minus 2y equals 2 and x plus 2y equals 6. This is what I'm looking for. I'm looking for one of the variables, the x or the y's, to have the same coefficient, in which both the x and y's have the same coefficient. And now, since the y is negative 2 and the positive 2, well, if I add these two coefficients together, then I'll see that I'll get these to cancel out. And that's what I want to do, is I want to eliminate one of the variables, the x or y's. So if I add these two equations together, and again, the two choices I have, I can add these or subtract these. In this case, I'm going to add them because they have opposite signs. So 1x plus 1x is 2x. Negative 2y plus 2y, well, that's just 0y, which is 0, equals, and 2 plus 6 is 8. So here I have x equals 4. So again, I have my x coordinate, and I need my y coordinate. So let's take this x and plug in for either equation. So I'm going to go into my first equation here. And again, you could go into any one of those. So 4 minus 2y equals 2. Solving this for 4, so we got negative 2y equals negative 2, and y is equal to 1. So the point of intersection is 4, 1. So I eliminated these through addition. They had the same coefficient, opposite signs, just add the two together, and you can eliminate one of the variables. You could do the same here if you have 5x minus y equals negative 1, and x minus y equals 3. So if you notice, my x's are not the same. This is 5x and 1x. However, this is negative 1y and negative 1y, so they have the same coefficient with the same signs. You have a choice here. You can multiply this by negative 1 and make this a positive, or you can simply just go from here and say, okay, I'm going to subtract the second quantity or second equation from the first equation. So this is 5x minus 1x. So 5x minus 1x, and I get 4x. This is negative 1y minus negative 1y, which in turn becomes plus 1y, which is 0, and that goes away. And then my last one is negative 1 minus 3, and I get equal to my negative 4. All right, so be careful. Make sure this negative sign, you're looking at the negative sign for each time you subtract. And then 4x equals negative 4x, and you get x equals equal to negative 1. So you have the x coordinate. Let's go and find our y coordinate now, and you can plug into either equation. So I'm going to say, okay, so 5 times negative 1 minus y equals negative 1. So this is negative 5 minus y equals negative 1. Negative y equals 4. Y equals negative 4. So negative 1, negative 4, is my point of intersection. Another type of problem we might have for elimination is when our coefficients are not the same. So in this case, we have negative 2x plus 10y equals 2, negative 3x minus 8y equals 3. So the x coefficients are not the same, the y coefficients are not the same. So I want to eliminate one of them. So what I want to do is I want to multiply both equations by something, or one equation by something, or whatever you have to at this point to get something to eliminate. So if I look at my 2 and 3, a common multiple of 2 and 3 is 6. So what can I multiply both these equations by so both those x's are 6? Well, the first equation needs to be multiplied by 3, because 3 times 2 is 6. The second equation I'm going to multiply by 2, because 2 times 3 is 6. I'm going to multiply, I like the addition, so I'm going to multiply this by a negative 2. So that my first term here is positive 6x, and this first term here is a negative 6x. So let's distribute this negative 3 to all three terms here. So we got negative 6x plus 30y equals 6. And my second equation here, distributing this all the way through, is positive 6x plus 16y equals positive 6. Okay, so multiplying through again. I'm going to eliminate 3 times negative 2x, negative 6x, plus 30y equals 6. 6x plus 8y equals, this should be negative 6. Alright, so if I add these together, negative 6x and positive 6x is 0. 30y plus 16y is 46y equals, and 6 plus negative 6 is 0. So if we solve this first one, divide by 46, and we see here that y is equal to 0. Take this y coordinate, so we have the y coordinate, and let's plug into one of my equations. So I have negative 2x plus 10y equals 2. I'm going to plug in, so negative 2x plus 10 times 0 equals 2. This simplifies out, so negative 2x equals 2, and we see that x is equal to negative 1. So the point of intersection for this system of equation is negative 1, 0. And we have two special cases here. And these special cases can arise from any method. 4x minus y equals 3, 4x minus y equals negative 3. Let's look at this one. If I want to eliminate, I could do. They both have the same coefficients, same signs, so I could do this elimination with subtraction. So 4x minus 4x, I get 0x. Negative y minus negative y is plus 0y, which in turn is just 0, equals. And 3 minus negative 3, which is 3 plus 3, which is 6. Now if you see that this is not a true statement, 0 does not equal 6. So this is going to be a no solution. And what that means graphically, that this is not going to be a solution here, if you take this equation 4x minus y equals 3, and just plug this into slope-intercept form for a second, you'll see that this, if you convert this, you'll see that y equals 4x minus 3. And if you do the same here, you'll get the same thing. You'll see that y equals 4x minus 3 again. I'm sorry, plus 3. If you notice, what's the slope here? The slope in this equation is 4. The slope in this equation is also 4. So both these lines have the same slope. So if both these lines have the same slope here, well then these lines are traveling in the same path with just different intercepts. So these two lines are parallel lines. What do we know about parallel lines? Well, the distance between them is always constant, and they never intersect. Well, if they never intersect, then I'll never find a point of intersection, which is why there is no solution. Our other extreme scenario is this next example, 2x plus 3y equals 6, 6x plus 9y equals 18. Okay, so I'm going to multiply my first equation here by 3, or negative 3 in this case, and I'm going to get negative 6x minus 6y equals negative 18, and my bottom equation stays the same, so in this case I only had to multiply one of them, and I have a small error here. This should be 9y. So negative 6x minus 9y, negative 18. I have my same coefficients, so I don't have to multiply this equation by anything. So if I do this, I get negative 6x plus 6x, I get 0. Negative 9y plus 9y, I get 0 equals negative 18 plus 18 is 0. So in this case, I have 0 equals 0. So here's another special case. Since they both have they're both equal to each other. So this is infinite amount of solutions. And what that means graphically is if you look at your equation here, if you look at a graph, whatever line I have, so if this is my line, then my other line is going to be right on top of that line. So the question is, where do they intersect? Well, in this case, both lines are on top of one another, so they intersect infinite amount of times. They're going to intersect an infinite amount of times everywhere on the line. So my solution would be infinite solutions. And again, I would look out for when both equations are equal to each other here, or in this case, when the equations are not equal to each other, when you get something like 0 equals 6. So no solution, parallel lines, infinite solutions, they're lines on one on top of one another.